Okay, the quantum mechanical view of the atom, otherwise known as the cloud model. You don't often hear this among physicists, but you might among other people. The year somewhere around 1926. Now it was certainly added to after that, but it's beginning to take shape around 1926. Okay, now a few points. One is that this model agrees with Bohr's model that electrons can only exist in discrete states, that they can't. Remember, Bohr took Rutherford's and said, okay, they can't be just anywhere in any orbit around the nucleus. They have to be in discrete spots. So this model agrees that they have to be in discrete states of definite energy and no others. And it agrees that in order for an electron to move from one state to another, it has to either absorb or emit a photon of energy. So it agrees with that. But this was Bohr's. But this model says, yeah, but the discrete states are not well-defined circular orbits like Bohr thought. So all that work that Bohr did to get his RNs, the radii of the different energy levels, they know, they're like, yeah, they're not circular orbits. They're rather thought to be spread out. They're like three-dimensional spread out clouds, which is where the cloud model comes from. Okay, so they see them as clouds, different shaped clouds, and it's in this model that we begin to call them orbitals. Orbitals. Okay, and the shape and the size of the cloud or the orbital can be calculated using quantum mechanics, using Schrodinger's equations. Remember the nice equation I showed you there a while ago. So using Schrodinger's equations, we can find the size and shape of the clouds, of the orbitals for all the different levels. We know that for the ground state, and this is where Bohr basing it on hydrogen came in, we know that for the ground state, the orbital is actually spherical. Okay, and so Bohr wasn't completely wrong. He did have the sphere. It just doesn't continue that way as you go up. And just like a cloud doesn't have a distinct defined edge, like if you look at the sky and look at a cloud, you'll see there's spots where it's darker white and spots where it's like wispy and light, and there's no real defined edge or boundary. And that, or defined even size. And that is the same as what we believe with these orbitals, that there's no defined edge or size, but there's spots where it's higher concentration or lower concentration, higher probability of finding the electron there or lower probability of finding the electron there. So just like a cloud is more dense, in these clouds, the more dense means higher probability of finding the electron there. We also know in this model that each orbital can be occupied by 0, 1, or 2 electrons at the most and no more. And we will get into the why, but not until tomorrow. We also know that when 2 electrons are in the same orbital, they have to have opposite spins. So maybe in in chemistry, you might have drawn the orbitals like coming out from the nucleus like this. So if there were 2 in there, one would have a spin up and one would have a spin down. They have to have opposite spins. For n equals 1, the n equals 1 orbital, we know it's a sphere. The n equals 2, they're like dumbbells or barbells for those of you that are into weightlifting. N equals 3, there's 2 different shapes. There's kind of a more elaborated barbell and then a more elaborated sphere, and then they go up from there. So they're all different shapes as we go up. Okay, and so in tomorrow's class, tomorrow's videos, we will begin to look at how these fill and why and all of that. The only piece of homework I want you to do tonight, the first thing we're going to talk about in the next video are the quantum numbers. So if we were in school, I would say to you, go home tonight and find at least the name of the 4 quantum numbers, because that's where we're going to start in the next video. Okay? Very good.